Okay, good day, future engineers. We'll continue our discussion on curvilinear motion on rectangular components. So last time we have our first example. We have a brief discussion on the introduction of the curvilinear motion and then a simple example. Now let's proceed with our second example. So with our second example, we have a plane here. So for a short time, the path of the plane is described by y is equal to 0.001 x squared. So, the path daw kuno ng giagian ni plane is described by this equation. Y is equal to 0.001 x squared. And take note of the unit that is in meters. If the plane is rising with a constant upward velocity of 10 meters per second, determine the magnitudes of the velocity and acceleration of the plane when it reaches an altitude of y is equal to 100 meters. Okay, let's write what are given in this problem. Now we have our y is equal to 0.001 x squared. Unit is in meters. We also have the plane. The cone is rising with a constant upward velocity. So constant upward velocity, that is Vy is equal to 10 meters per seconds. And what else? We're asked to find the magnitude of the velocity and the magnitude also of the acceleration at y when the altitude of the plane or at y is equal to 100 meters. So sa may buhaton na to ani okay, we have our Vy is equal to 10 meters per seconds. That is constant. Therefore, our acceleration along y is equal to 0. We also have our position or the equation of the path is equal to y is equal to 0.001 x squared, and then that is in meters. Now, how are we gonna find since getting the magnitude of the velocity is equal to the square of the velocity along the x and square of the velocity along y. We have dy, but we don't have the velocity along x. So saan mo nato napagkuha? Since we don't have other relation directly, no, there is no explicit formula here that we can substitute for the x. Then actually we can differentiate the y with respect to the time. So we will have Vy is equal to, we can differentiate this one, that is 0 point, by power rule, we have 0.002 x. And since this is an implicit differentiation, don't forget to write dx over dt because we are differentiating this whole equation with respect to time. And since there is no time function on the right side that is on the x, then we need to write the dx over dt. So now we have Vy is equal to 0.002 x. And take note that dx over dt is the velocity along x. Since we have a value for a velocity along y that is equals to 10, and we have the 0.002 x vx, we can have that our velocity along x is just equal to 5,000 over x. Now, are we gonna find this one? Unsa man si x? Let's use the formula. Y is equal to 0.001 x squared. So natin given nga y is equal to 100 meters. So at y is equal to 100 meters, makuha na to si x. Yeah, we will have x squared is equal to 100 over 0.001, or that is just simply 100,000. We just extract that to square root, and you will have that at y is equal to 100 meters, our x is equal to 316.228 meters. So we can use this value and substitute it here. Then we can have that the velocity along x is just equal to 15.811 meters per seconds. Since we already have our velocity along x and velocity along y, then we can solve for the magnitude of the velocity. So we have 15.811 squared plus we have our 10 squared for the velocity along y. So the magnitude of the velocity is just equal to 18.708 meters per seconds. Siya. Next, we're going to find the acceleration magnitude of the acceleration. So again, we have the formula again that Vy is equal to 0.002x Vx. Now, if we differentiate this whole equation with respect to time, we will have that acceleration along y is equal to, so this one of the byproduct rule, we will have 0.002 x times dvx over dt plus vx times 0.002 course times dx over dt. So we'll have our acceleration along y is equal to 0.002 x, and dvx over dt is just the acceleration along x, plus we have the vx times 0.002 and times another vx. So we'll have ay is equal to 0.002x ax plus 0.002 vx squared. Since ay is equal to 0 because our velocity along y is already constant upward, so we'll have 0.002x ax and 0.002 vx squared. So by rewriting this one, we can arrive that our acceleration along x is just equal to negative 0.791 meters per seconds squared. And since our ax is a negative 0.791 meters per second squared, and our ay is equal to 0, so the magnitude of our acceleration, which is equal to the square of the velocity along x plus the square of the velocity along y, and we'll have that our acceleration is just equal to 0.791 meters per second squared. Then this is your final answer for this specific problem. So Matushano, take note that first, you analyze what are given. So here we have the equation of the path, and we also have a constant velocity. And we're asked to find the magnitude of the velocity and the magnitude of the acceleration. And in order to find the magnitude of the velocity, dapat natay velocity along x and velocity along y. But how can we get the velocity along y? So we just differentiate the position of the function that is given by the path of the plane, and but the function of the y is a function of x. Now, but differentiating that with respect to time, we arrive with this one that is implicitly So at every time that we differentiate with respect to x, dx with respect to time, dapat yun natin ipakita ngayon nga ni dx over dt, and that is equal to the velocity along x. And from there, we got the velocity along x equation. And then finally, we got our velocity along x. Same also with the acceleration. We just use the same equation, no, to get the acceleration along x. Since the velocity along y is constant, therefore, if ato difference is a constant, that will become 0. And then here on the right side, if we differentiate that, you can see that there are two variables here. We have x. We also have the vx. So we just differentiate this expression here with respect to time, and using the product rule, then we arrive with this solution. And then since our acceleration on y is 0, we were able to solve that the acceleration along x is equal to negative 0.791 meters per second squared. And therefore, our magnitude of the acceleration, which is the square equal to the square root of the sum of the squares of the acceleration along x and along y. And finally, we get our final answer, which is equal to 0.791 meters per second.